All right, so we're going to take a quick look at some of the rubric as we continue thinking about the next deadline, the calculations. So we've talked a little bit about this part of the rubric before, but again, just highlighting several of the various key things to jump from 1 to 2, 2 to 3. 3, again, in this category is very difficult to get, as we've experienced in the past. So you really have to be explaining and talking about your data and talking in detail about your data and how it's collected and how it's valid and so forth, right? So just make sure you are discussing, right? Make sure you pay attention to that outline for the introduction, and you are discussing your data and the process of data collection and so forth. I really want to talk more about criterion C because that is the calculation criterion. So a couple things to point out. To get a 0, the product does not contain any mathematical processes. That is almost impossible. So at least 2 simple mathematical processes carried out. Remember, that is mean, standard deviation, any visual representation, graphs, right? It gives you a list of things here. Remember that blue half sheet, that is something that you need to look at and make sure you have your simple processes. Almost all projects have some sort of graph, and then most would do mean, median, maybe some ranges, if that makes sense. But then graph, mean, median, and then standard deviation is often a good one to look at in terms of dispersion of your data. And then from there, we start looking at correctness, right? So to jump from 1 to 2, at least 2 processes have been carried out correctly. To a 3, at least 2 simple mathematical processes have been carried out correctly. All are relevant. This means if you do a calculation or you create a graph and you can't tell me something about your data now from that calculation, it wasn't relevant. If you can't make an interpretation or say something after you make a calculation about your data now, then you shouldn't be using that calculation. Or you just need to do some research and figure out why. Why would you use the mean? And research that a little bit. Or standard deviation, what does that tell you? Okay, so then use that to help you make your interpretation, right? So make sure you're on top of that. Number 4, or to get up into a 4, simple mathematical processes have been carried out correctly. In addition, at least 1 relevant further process has been carried out. There's your chi-squared correlation, okay? So most of you, for the further chi-square or correlation, okay? To get up to a 5, it really shouldn't be that difficult, but it's all are relevant, all, at least 1 relevant further process. So everything has been carried out correctly, 100% precise, all relevant further, all relevant to the aim of your project, and all without error. Just again, the calculations, there are other details that go into some of these things. Like, for example, the mean, median, you actually need to show how do you calculate the mean. Show the calculation. For standard deviation, there is again, a video in that playlist, the YouTube playlist, videos that help you go through standard deviation to show your work through Excel. But again, there's work that you need to show. When there's a formula used, you need to show the formula. So you need to, at this point, do your best to make all of your calculations and put down all relevant work. And then that's the point of the peer evaluation. That time we can use to help make sure everything's there that needs to be. And then we have a little chunk of time to really make sure we get all that included between now and your rough draft being due, right? Your rough draft deadline, okay? So calculations are important. Make sure error on the side of too much work, and we can always pare it back, right? We can always cut it down or get rid of unnecessary repetitive processes, but always start with showing too much work, right? Basically, okay? So organized data, again, you should have, if you did a survey, you should have your surveys already recorded in your table. That's basically what you turned into me for that first data deadline. And especially if you're doing correlation, I mean, really, this is what your data would look like anyway. All right, so there's your raw data, okay? Organized data would be then your observed table, right, for chi-squared. And in this case, this is comparing number of hot dogs a person can eat in 5 minutes compared to grade level. And in this case, just talking again about some of the issues you might run into. Remember, expected value is less than 5. That can't happen. So sometimes I might have made intervals, right? So I chose the intervals of 1 to 2, 3 to 4, 5 to 6, but I have an expected value less than 5. That means I need to go back and regroup my intervals. I need to redo those intervals. So now I made intervals from 1 to 3 and 4 to 6. So now I only have 2 intervals, but that still gives me a valid test because now I don't have expected values less than 5. Notice right here now, the expected value is 9.74. Okay? So that is something that you do need to be aware of. It is possible maybe I would have had to combine this into, maybe I would have combined upperclassmen and then 9th and 10th. That might have been a way to combine that to avoid expected values less than 5. Right? There are different ways to do that, but that is something you have to consider. For correlation, here's an example of correlation, raw data in your lists. And then for your actual correlation calculation, you would only use 2 of those variables at a time. And then you would create columns. Again, there's a video on in that YouTube playlist that shows you how to do correlation, making Excel do most of the work. But the work that you need to show is still it's shown in that video. Okay? So correlation, the formula, especially in that video, I believe, the formula they use is this. That is something that you will need to show in your project, and then the work following is what you plug into that formula to show your value of R. Okay, linear regression, right? Equation of the regression line is this formula here. Again, there are videos that will help you through that, and that was it, I guess. So at this point, make sure you finish the coordinate geometry. Right, so the coordinate geometry homework check on Canvas. That is something that needs to be done. That will close Sunday, 11:59. Do everything that you can do at this point for deadline number 3. Calculations, data, organize data and all your calculations. So every calculation you think you're going to make, do it, show work, and we will go from there. We will answer questions, figure it out from there.